in class. Okay, so this morning I'm going to utilize you guys as people to collect some data on. So I will give you credit for doing this. This will be part of your class participation day, but it's not graded on whether you get it right or wrong. It's just graded on you participating and giving a valid attempt. So if you do pretty well on it, I'll be impressed, and maybe I'll give you even more of a grade. But before we begin, let's begin with a prayer this morning. Let's see, Walter, can you lead us in our prayer this morning?
Yes, ma'am.
Thank you.
In the name of the Father, the Son, and the Holy Spirit. Our Father, who art in heaven, hallowed be thy name. Thy kingdom come, thy will be done, on earth as it is in heaven. Give us this day our daily bread, and forgive us our trespasses, as we forgive those who trespass against us. And lead us not into temptation, but deliver us from evil.
Amen. Thank you very much. Thank you. Today's mustard seeds I think it seems a little silly, but I guess it has a point. You ready for this one? It says, next time you see a mother with a child in a carriage struggling to get up a flight of stairs, help her. So I guess the point is, help those that are in need whenever it is plain in front of you that somebody might need something. I think it's that you are to step aside and assist. So we're not getting out and about too much to be able to observe those kinds of things, but maybe even within your household. I know I always laugh that when people are sitting and watching TV and I'm scrambling to get dinner together or doing dishes, or I seem to be so busy, which I think is most mothers' ways. It's nice when somebody just says, can I help you? It's a nice thing. All right, gentlemen, give me a smile this morning. Movement. Anything? Wes, give me a smile. Oh, he's not paying attention to me at all. Wes, you with us? He looks like he's totally ignoring me. Or behind. All right, gentlemen, here's what we're going to do this morning for this science experiment. It has to do with your memory. So first thing this morning, I'm going to give you a picture. The picture has a bunch of shapes, and each shape is a different color. Okay? Wes, that's good. He said his audio is not working. So let's see. All right, so I'm going to give you this picture. You are to look at it and study the shape and the color. And then I'm going to send you, you should have in your email a Google form that is going to ask you what shape goes with what color. Okay? So you're going to test that out this morning. All right, so I'm going to do a screen share. Maybe I'll wait to see when Wes gets back with us. And we'll do a screen share and take a look. Oh, here he is. Let's see if it works this time. All right, Wes, hopefully that'll work. Good? Working now? Awesome, awesome. All right, everybody ready? Be focused. And so here's how this is going to work. I'm going to time it and give you a few minutes to take a look at the picture that I'm going to send you. And then, so let's see, I'll go to my stopwatch. You get, let's say, 2 minutes to take a look at the picture. And then we are going to take a survey. So let's see, not seeing the picture. There we go. All right, we ready? There you go. So study each shape and the color. No writing it down.
Wait, so we got to remember the color,
and the shape. So you have to say, like, the circle is yellow. Don't write anything down. And it's just for fun. So we want to see what shape, come up with some kind of way of remembering this.
Wait, so do we not put it in the survey?
Don't do it in the survey. No, don't open up your email. You got to do that without the picture. Don't write anything down, Josh. Are you writing something down? No,
I'm
you're writing
not.
it
I'm
down.
not. I'm
It's
not.
not a grade. It's just a test to see how well your memory is.
I don't have good memory.
Me either. Ten seconds. Okay. Now what I want you to do is go to your email and you have a Google form that says survey. So I sent you an email that says survey. Go to that Google form. No cheating, no screenshots or anything like that. And answer the questions on the Google form. Give you a few minutes to do that, and then we'll get back to class today. This is part of your participation grade today. So please participate. Everybody able to get the form?
Ms. Rajiv, I didn't get it.
You didn't get it, David? Okay, I'll
I
send
didn't, I
it.
didn't, I didn't get it either.
All right, look again.
I got it.
Okay, let me get on my email and I'll send it to you directly.
Ms. Eisenhower,
Yes.
I don't know these.
That's okay if you don't know any. Walter, I just have, I think, your dad's email.
Oh,
You still not get it?
no.
Miss Reisenweaver, on the Google form, it just
Chat me
says
your
like,
email address.
Huh?
Chat me your email address. Okay, I did notice on the Google form, it said like, there's one thing that says option 1, just ignore that. I think it was a mistake putting that in there.
Miss Reisenweaver, is there a diamond on there?
I'd have to go back and even look 1 second. Yes, there's a diamond. Okay, Walter, it should have came.
All right.
Miss Rosenweaver,
Mm-hmm.
there's a
Yes.
random like option. It says option 1. What is
Yeah,
that?
just ignore that. I saw that too. I'll have to let them know to take that out.
Okay.
So David, or Joseph, I keep wanting David. So just to show it to you again, see how you did. If you can even remember what your answers were. So Joseph, it really wasn't a diamond, but called a rhombus. So that's a tricky one. So in the question, it asked you, what was the shape of the diamond? It never said rhombus. So I would call that a diamond, but kind of laying on its side. Anybody think they got them all right? So when you do something like that, I'm just too curious. Marquise, what kind of strategy did you have to try to remember as many as you could? You're muted. All right, you're muted. I didn't hear any
My
of that.
bad.
There you go. Start over again.
I try to like match the first letter of the word. So like what was the first one? Circle. And it was yellow, so I said like O and Y, and I tried to remember it like that.
Oh, very good. I like that. I personally would have probably picked 2 or 3, so I knew I at least got something right and just concentrated on those because I knew I would not have a chance with all of them. Well, I'll be curious to see how you all did. All right, so speaking of how you did on little quizzes and tests, so Makai, you will take a makeup test, but you'll benefit from hearing this a little bit. I just want to explain on your quiz, the way that I graded them is you were given your grade based on the multiple choice. And then so the quiz grade itself was only 19 points. But I gave you points that were kind of extra credit on top for your problems. So the more you did on the problems, the better you did. Some of you did even more, got more than 100% on this because your problems were so good. So I added on to it what I felt that you did with your problems. So real quick, before we continue, I want to discuss the 2 problems that, or at least one of them that you saw on the quiz. So let me pull up, I guess I'll have to do it this way. Okay, so we don't want that anymore. Okay, get into my Google. There it is. All right, so your quiz. Take a look at this. If I scroll down to the bottom. All right, so one thing, too many of you didn't show me much work at all. You just answered it. So if you showed me work, then we were able to see a little bit more. Well, what I would be looking for here, a 5 kilogram blob is thrown horizontally 4 meters per second, hits another one that is sitting at rest on a frictionless surface, okay? The next question says, a 1,000 kilogram car moving 20 meters per second. So what you'd have to do up here, what I would be looking for in your texting, it's not gonna let me change that. All right, so real quick, I'm going to stop that share and solve that up here real quick. All right, so looking at your work. This is very similar to what we had in homework. You have a 5 kilogram blob, right? Moving with a speed of 4 meters per second, another 5 kilogram with a speed of 0, and then the two stick together. So altogether, your mass here would be 10 kilograms, or 5 and 5. And the question was, how fast do they move afterwards? So over here, you would have M1V1 plus M1V2 equals M1V1 prime plus M2V2 prime. So you'd have 5 kilograms times 4 meters per second plus 5 kilograms times 0 is equal to, how fast are they moving afterwards? 5 kilograms times V1 prime plus 5 kilograms V prime. So we're going to call both of those V primes, right? Afterwards. So over here, you would have just had 20 plus 0 is equal to 10 times V prime. You would add those two values together of 10. 10 times V prime, to get the V prime by itself, we're going to divide both sides by 10. So 20 divided by 10 is going to give me 2 meters per second, is going to be your speed afterwards. So you could have gotten that right. If you got it right, you got a point, because you could do it also just in your head to say mass doubled, so speed would have to be half as much. All right? So that would be our first problem. Any questions on that? No? All right, now I should probably go through and show you a little bit more multiple choice. So what I did recognize when I took a look at the multiple choice was that, of course, if you missed one, maybe on impulse or something like that, you might have missed the other one as well. So I'll take that into consideration as I compute the grades on this. But let's look at this last problem right here. A 1,000 kilogram car moving east with a speed of 20 hits a 750 kilogram car moving west with a speed of 25. The cars stick together. How fast will they be going afterwards? So again, they stick together, right? So 1,000 kilogram moving 20. So what do we have over here? A big car, 1,000 kilograms with a speed of 20 meters per second. We have a little bit of a smaller car, 750 kilograms, moving with a speed of 25 meters per second. But one's moving east and one's moving west, so they're moving in opposite directions. So this speed I have to write in as a negative 25. Afterwards, the two cars again stick together. What is their speed after? So if they stick together, we're just going to add their masses together. Over here, you'd have 1,000 kilograms times 20 plus 750 kilograms times negative 25, right? And that's going to be equal on the right side to the two of them sticking together. So on the right side, we'd have a total mass of 1,750 kilograms moving with some speed. So we've done enough problems to recognize that that mass is just going to add together and we'll have a final speed, right? So here's the mistake most of you made. You didn't make one of those velocities negative. And so these numbers would end up subtracting from one another, and we would divide on this side, and I think it comes out to be, so you'd obviously have 20,000 minus 25 times 750, 18,750 equals 1,750 times V prime. So you divide by the 1750 to get your V prime by itself. And what you would find here is this number is greater than that, so you end up with a positive number, and that positive number means that it's going to continue moving in that direction, and it's 0.71 meters per second equals v prime. So not very fast, but it's going to be positive, and it's going to move in the direction of the bigger car, even though this one is moving with a greater velocity. Okay? So the one that has the greater momentum is where it's going to be moving in that direction. All right, so that's a quick going over your quiz. Does anybody have any questions on those problems? All good on the problems? Let me just show you your multiple choice real quick if we go back to those. Does anybody have any questions on some of these multiple choice? So you probably don't remember which ones you might have missed or any of them that you want to discuss.
No, not me.
This is the hard part of, somebody had something to say? Everybody good with that? All right, so the hard part of that is it was in instantaneous where you looked at your quiz, so I don't necessarily have it to give back to you. If you want to come back during my office hours, I can certainly pull up your individual quiz and show it to you, and I'd be happy to go over it with you. So at 2 o'clock today, 2 o'clock tomorrow, 10 o'clock on Friday is my office hours that I would be happy to go over with you. Okay? All right. Any questions? You're all good? All right, everybody look into their camera. Show me that you're paying attention. Jacob, you paying attention? Give me 100%. All right, 100% focus. All right, we have something new coming up here today. So that was momentum. Next, we want to talk about energy. Energy, which you guys have very little of right now, right? Walt, give me a definition of energy. What do you think energy is?
Like, do you mean energy like a human's energy to do something, like they're not tired?
Okay.
Or like in an object, like the amount of like force or something?
Okay, the amount of force. I like all that you said. It actually comes into play. Force is involved in it. So the amount of force. And you said people can do something, right? You said energy, I'm going to.
Like they feel like do something.
I can do something. Good. Marquise, what's your thought about energy?
I think energy is, I would say, the strength of a human being or living thing. It can be physically or mentally.
Okay. It can be physical, mental, energy. Any of you guys interested in studying business as your future career? Marquise, have you been paying attention to the oil crisis that's going on in business? Well, if you pay attention in the stock market, we've hit a historical marking, and that is that oil is in the negatives, which means it's cheaper to give you my oil than for me to keep it. So to store it, to process it, I'm not making enough money. There's so much oil in the world that they almost need to give it away. And so the question is, okay, well, what does that mean for our gases? That gas, you know, if you haven't noticed, gas prices have gone way down. I think it was $1.60 the other day that I paid for gas. So anyway, energy. When you think of energy, both of you kind of thought about people. What in terms of energy, as far as we are in this new, alternative energy mode? Environmentally, we have to find our wind, our solar, our, alternative energy sources besides oil and our fossil fuels, right? So energy. Josh Davis, what about you? Any thoughts on what you think energy might be?
I think it's like the strength and like the motivation.
Okay.
Yeah, it's basically what I think it is. Strength that takes you to do something, or your motivation. Yeah.
Okay. So right now, Makai, given the definitions we just heard, On a scale of 1 to 5, 5 being the highest, how much energy do you have right now?
1.
1, I would agree. It took you like 15 seconds to reach the finger over to unmute. Which brings up Walter's point, energy, the ability to do something. Okay, you guys are doing very good. So what does that have to do with mentally, physically? I've said this before, you know, when we talk about God and faith, which is, I like to bring up in our science classes, you know, when I love the concept of energy, I definitely think in terms of energy. And if you think in terms of energy in our world, it answers so many questions. And for me, people that are filled with the Spirit, you say, they are filled with the Spirit, they show a lot of energy. They show a tremendous amount of energy. So I personally don't think of God like I think of Jesus. Jesus was the person representing God. God is somehow some form of energy, because when I'm filled with that Spirit, there's a lot of energy in the definition of what you guys were saying. The ability to do something, the ability to, right, be excited, be energetic. Wow, our definition of energy, okay? Energy, so here's for your notes. Okay, energy is, Walter, you almost had it perfectly. The ability to do work. If you have energy, you have the ability to do something. You have the ability to do work. Which one is that? Okay. So what exactly is work? And Walter, you were close on this one too. Work. Okay. By definition, is a force applied over a distance. So work is a force applied over a distance. So if you have energy, you have the ability to do work, which means you have the ability to apply a force through a certain distance, not just have it, but actually move something, actually cause it to change its position. So in momentum, we looked at impulse, which is force and time. In energy, we look at force over distances. So energy, the concept of energy is the ability to do work. All right, so I'm going to write up here while we are working here that this is chapter 7 in your textbook. So your homework tonight is to take a look at chapter 7. Okay? And all I want you to do is glance through it. I want you to take a look at, let's see, read sections 1 through 3, which is pages, if you have the 12th edition, 110 to 115. Okay, so that's part of your homework. The second part is we're going to work on a little bit of a project regarding energy. Energy is the ability to do work. If I can do work, I cause forces on objects and make them move from one place to another, which means I can do something. I can make something happen. Okay? So when I make something happen, I have the ability to do something. Have any of you guys ever heard of a Rube Goldberg experiment? All right, the second half of your homework is going to be in your house that you've spent so much time in, is to gather some supplies to build me a Rube Goldberg. All right, here's an example. Jacob, are you paying attention or are you playing a video game? Your both thumbs are doing something right there.
I'm paying attention.
What's in your
It's just
hand?
my phone. My phone's on the charger. I don't got nothing in my hands. I'm just
All right. I need to see that your face is this way. All
I
right.
can, but
I'm not sure how this sound will come through, but this is so cool. I want you to watch this YouTube video. This is an example of an extreme Rube Goldberg project. Now, a Rube Goldberg is you are going to convert different forms of energy into doing something that is very simple. So by definition, a Rube Goldberg makes doing a simple task even more complicated, which is kind of what physics has been all year, right? Takes the common sense and seems to make it more complicated. So what I need with you right now is I'm going to share my screen and share with you this video. Hopefully you'll be able to see or hear the, let's see if I can move this down. There we go. All right. So again, a Rube Goldberg is going to, see if I can expand that, make something very simple happen. So this man, okay, can you build that? Did you all watch that? All right, that was a very, very elaborate Rube Goldberg. But I'm sure all of you have set up dominoes in the past. Makai, I need you to sit up and put your hood down, show some energy. All right, so when you hit the dominoes, and it has the domino effect. So what you saw there is by the initiation of just one object falling, you had this this energy that was transferred from one object to another, and in the end, accomplished a very, very simple task, right? So your homework this weekend, along with taking a look at energy, I have a assignment that's going to take you up to the end of the year, and it's to design something like that. This is a huge grade, so it will count as a test grade at the end. So let me share with you your Rube Goldberg challenge, okay, and description. So you will find this on Blackbaud in your course documents. I will put it on there for you guys to have. And these are your rules. Okay, so all year we have been doing design challenges. This is the finale. Okay, so let me share this with you. Hold on 1 second. Makai, if you're not going to stay awake, you may dismiss yourself from class. And you don't get my time later for making up your quiz if you're not paying attention. All right, so let me screen share this with you real quick, and you can understand your expectations of what you're going to do in your project. So let's see where it might be. There it is. Okay, here is your challenge called the Rube Goldberg. Rube Goldberg is a machine or a contraption, invention, that apparatus that deliberately over-engineered to perform a simple task in a complicated fashion. Generally, a chain reaction, the domino effect as mentioned. Your challenge is that in your contraption, work is done on one object that causes a chain reaction, or what we would say in physics is a constant change in energy from potential energy to kinetic energy. In the end, the work done to get to the machine started triggers another object to accomplish a simple task. Your building constraints. You must use materials found in your house. Do not use materials that anybody wants to keep using, because you're going to need them stocked away for a couple weeks. You must chain energy forms a minimum of 3 times. Next week, we're going to learn about kinetic and potential energy. A simple task must be completed in the end. Making a basket like a basketball shot, picking up an item, closing an object, passing the salt, as you saw in the video. Prior to showing your machine, you must state the task that will be accomplished. So you are going to show this live in a video when we get together on May 13th and 14th. That's the second to last week of classes. on Zoom, you're going to be able to, you're going to use your camera and you're going to show me your Rube Goldberg machine. You must consider how the Zoom is going to work. So can you move your camera, or are you going to have to build it right in front of your desktop computer? You will be allowed 3 trials. After each attempt, you will be allowed 1 minute to make adjustments as needed. Your machine must take anywhere from 10 to 60 seconds. The video that I showed you took 5 minutes. That's way too long. Now, if you want to make it that elaborate, that's impressive. You must be able to answer questions regarding conservation of energy, and you must show evidence of working towards your final project next week on Wednesday and Thursday. So your homework is to start playing around with this, trying to think of ideas, okay? All of you probably have Hot Wheel cars, Hot Wheel tracks, maybe Lincoln Logs, Legos, none of that? You have paper, you have marbles, you have tennis balls, baseballs, basketballs. Now, you can Google. The best thing to do is Google.
So it's due next Thursday?
No, it is not due next Thursday. A
This Thursday.
beginning of it is due next Thursday. So the whole thing is, you have to show me you're coming up with ideas, that you're working towards it.
Oh, so it's not due this Thursday then?
It's due the following Thursday, the 13th and 14th of May.
All right. Okay.
All right, so this document is shared. It's going to be shared with you on Blackbaud. You can get on. Now, the best thing to do for homework this weekend is Google and watch YouTube videos on Rube Goldberg machines. It's pretty cool. If you get it accomplished, it's just so neat to see something like that work. When we talk about conservation of energy, and it is, the whole economy is based a lot on energy. Wes, do you have a question?
Mhm.
Yes.
It's gonna be hard to do.
The video I showed you is really hard. Those guys are professionals. They actually make a bunch of videos like those, and that's all they do. However,
Like,
yours
what do we
could be
have
as
to do?
simple as knocking dominoes over that cause something to fall off a table that pulls down on a string, and a spoon throws a ball across and you make a basket.
It's still hard to do.
It is hard to do, but something fun, something different than paper and solving problems, right? So I thought this would be a little bit more fun and engaging for you guys. I want to remind you of something else. So a couple other grades. Next Thursday will be our last boot camp Friday. And I told you I was going to extend the juggling. Next Thursday will be the last day that you, and if you want to show it to me, it's going to be live. You're going to juggle in front of the camera for me. If your class does the longest amount of time total, you get extra credit. So, Wes, I'm going to put a plug in for you. This is probably your best grade you've had all year. And you're motivated because you need that, right? All of you should be getting the best grade you get all year right now, because quite honestly, they're easier grades. Your quizzes are no open notes and everything. So don't let up on that, because this grade averages with everything. All right, so some long-term things. Juggling next Thursday. Rube Goldberg research. Just Google it, play around, start building things. You have all this time, play. I want you to play and build things. And read chapter 7, taking a look at energy, okay? And what we're doing in these Rube Goldberg is you're converting potential energy to kinetic. You're taking things and making them move. All right, everybody, got any questions? Smile. You may smile and say goodbye. I'll see you guys next week. Have a great weekend. Jacob, nice smile. Good to see your face finally.
My phone's on the charger.
You have one of the best smiles. You need to show it more often.
Thank you. All right. Bye,
All right.
George.
Bye. See you, Walter.